Okay, so for optimization problems, so we can use the theory of maximum of minimum functions. Important step, first step, normally what we do, we get the information. So we identify the variable given and equation needed. So you have to identify what are the variable or what are the quantity that you want to maximize or minimize. Let's say a value of unknown y. Let's say a variable y. So first step, normally from the information, we get the information, we have to know what's your variables. So which variables mean what quantity are ongoing to change in order to get the dimension maximum or minimum. So, and you have to know what is the shape involving here. Alright, so step number 2, let's say you already read the questions, you already know what is the variable that you're going to maximum or minimum. So your equation, so let's say y to be maximum or minimum, so your y equation should be expressed in a single variable function like y in terms of x. So number 2 is getting the formula in single variable. Then you're going to differentiate it. Alright, you're going to find the critical number, you differentiate it, you let it to be 0, and then you solve what's your critical number. Let your dy dx equals to 0. So find out what's your critical number here. After that, step number 4, we're going to test your critical number using second derivative test. So find your d2y dx squared so that you can test the critical number, whether you can verify it maximum or minimum. Lastly, you have to read back your questions so that you can use your critical number to answer the question what do you want to find. Is it they ask on critical number or they ask for value? Okay, so we look on example 7. So let's say a rectangular have a constant parameter. So you can see your quantity here, parameter. So parameter is constant. However, how do you adjust this dimension? Your parameter is constant. So that will be your first variable, constant parameter. And then what is changing? What's your variable? Your variable will be your length and your width. So that you can adjust it to obtain maximum area. So your variable here is your length and your width. Your constant here is your parameter. So find the maximum area. So first thing we define our unknown. Let's say x is about our width of this rectangle. Y is your length of the rectangle. And then the unknown that you want to maximum here is area. So area stands for your A. So that will be our first step. Identify the variable, identify the quantity, then identify your shape. Your shape is rectangle now. And then you have to focus on the variable to be maximized, minimized. So the variable to be maximized, minimized here will be area. So second step will be focus on your formula in a single variable. So look at the area. If I want to form an area formula, it will be need length times with your width. So length and your width, there are variables. Mereka adalah pemboleh ubah yang bertukar-tukar. So that you want to get your maximum. So you can see your A is equals to x times y. So your A is in two variables now. So they are not in single variable. So to differentiate this, you must obtain second step, you must obtain your formula in your single variable. So means x and y here, they have their relationship. They have their relationship so that you can express whether A in terms of y or A in terms of X only, but not in two variables X and Y. So look at your variable X and Y. What's their relationship? From here we can notice that X and Y here, they form a constant parameter. So from here we know that 2y plus 2x, they're supposed to get a constant parameter. So we can get a relationship on our X and Y. So we can substitute, we can express our Y here. So divide by 2. So Y in terms of X already. So this is our first step. So this is our second step. So once we know that Y can be equals to 1 over 2p minus x, we can substitute to our formula. So our area will be x times 1 over 2p minus x. So we obtain the formula where it is in a single variable. P is not your variable, P is a constant. Dia takkan berubah-ubah. Parameter dia constant. Yang kamu berubah-ubah adalah length dengan y. Okay, supaya kamu perubahan tu memberikan maximum result, maximum area. So that will be your step 2. So step 3, we're going to find out what's the critical number here. So we're going to differentiate it, differentiate A respect to x. So expand this, this is 1 over 2px minus x squared. So differentiate A respect to x. So 1 over 2p. So p is constant, nombor, tapi tidak diberi apa dekat nombor, tapi constant. So differentiate 2x, we get, differentiate x squared, we get 2x. Find out this critical number. So we will let our first derivative equals to 0. So 1 over 2p minus 2x here equals to 0. So find out your x. So 2x equals to 1 over 2p. Then your critical number here, x will be 1 over 4p. Then after that, step number 4, we're going to verify it using second derivative test. So we're going to differentiate again. d2a dx squared. So differentiate a constant will result you 0. Differentiate 2x will get you negative 2. So negative 2 in second derivative test, it less than 0. It is concave downward. Means we managed to verify your variable x here is in the situation of maximum with the value 1 over 4p. So after we verify this, lastly, we answer the questions. Look at the question. What's the question asked us to perform here? They ask you to find what is your length, what's your width, and then what's your maximum area. So we have the width already. So what's your length? Length will be our y. So what's your y? So for y, it is equals to 1 over 2p minus x. X is 1 over 4p. So our length will be equals to 1 over 4p also. So finally, answer what's the area maximum here. With using the critical number that we already verified, so other unknowns here all will be automatic maximum. Okay? So area maximum, area will be equals to length time with our y, x times y. So we'll give you 16p squared.